Here's a wild idea for you. Could we, one day, actually recreate a human mind? I know, it sounds like something straight out of a sci-fi movie. But what if it's not? The source material for today's explainer makes a really fascinating case that this incredible feat might be a lot closer to science fact than you think. Right, let's start on common ground. We all get it. The human brain is just unbelievably complex. It's this beautiful, intricate web of billions of neurons, trillions of connections. I mean, we're just scratching the surface of understanding it. It's everything we are. So it's totally natural to assume it's just way too complicated to ever fully map out, let alone try to rebuild. But what if that core assumption, that the brain is simply too complex, is just a failure of imagination on our part? What if we're just looking at the problem all wrong? Let's dive into a radically different way of thinking about this. And here it is, laid out plain and simple. The big idea is that no matter how ridiculously complex the brain is, it's still a physical system. It follows rules we can observe. And if you can observe something, the source argues, then eventually you can recreate it. That's the minding-bending premise we're digging into today. Now, a claim that huge needs some backup, right? Where does all this confidence come from? Well, the source points to a single but really powerful example from the world of science. Let's take a look at the lesson we can learn from the humble fly. That's the line right there. We did it to flies. See, back in 2023, scientists actually announced they had mapped the entire brain of a fruit fly larva. This map, they call it a connectome, is basically a perfect wiring diagram of its whole neural network. It's the most complex one we've ever finished, and yeah, a fly larva might sound small, but the implications are just enormous. So here's how the logic breaks down. First, we proved we could fully map a simpler neural system. That's step one. Second, that achievement is now our proof of concept. It shows the basic task isn't impossible. And if that's true, well, the argument goes that mapping the human brain is no longer a question of if, but a question of when. It just becomes a massive challenge of scale, not a challenge of possibility. And this, of course, leads us to the first of two huge questions that our source material puts right on the table. It's one thing to say it's just a matter of scale, but what does that scale even look like? So yeah, how could it possibly be done? This question forces us to get real for a second, to move past the philosophy and look at the gigantic, practical hurdles we'd have to overcome. What would it actually take to map and rebuild a mind? When you get down to it, the challenges are really three massive problems. First, you've got the observation problem. How do you even see every single one of the trillions of connections in a living brain? Second, the recreation problem. Okay, once you see it, how in the world do you build something that perfectly copies that structure? And finally, the absolutely staggering problem of scale. A fly brain has, 3,000 neurons? The human brain has around 86 billion. That leap is almost impossible to wrap your head around. But here's the thing. The source doesn't just get stuck on the how, the method. It pairs that practical question with a much, much deeper one about the why, the meaning. You can't really have one without the other. Together, they form the complete picture. And that brings us to the second, and maybe even more profound part of this whole idea. Let's just pretend for a minute we could solve the how. The very next question has to be, so what? So what is the real importance of this? Why would humanity pour unbelievable amounts of time, energy, and resources into a project like this? What's the endgame? The answer isn't simple, and honestly, it could completely reshape everything we know about ourselves. I mean, the stakes here are just monumental. It would touch almost every part of our lives. Think about medicine. A complete brain map could potentially unlock cures for diseases like Alzheimer's or Parkinson's. Or philosophy, we might finally get a real answer to the mystery of consciousness itself. And of course, in technology, this is basically the ultimate goal of artificial intelligence. The impact wouldn't just be big, it would be total. So we've looked at the what, the why, and the how. Let's circle all the way back to the source's fundamental belief. Is this future really something we can achieve? The source lands on this really determined statement. Despite all the challenges we just talked about, the core belief is that this goal is not impossible. The wording is so careful, right? It's not saying it's easy, it's not saying it's happening tomorrow, but it's saying it is not non-achievable. It's a double negative that just screams gritty optimism. And I think that's the most important takeaway here. Our source material today wasn't a scientific paper giving us a detailed roadmap. It was something else entirely. It was like a philosophical starting gun. It's a declaration of faith in what's possible, and maybe more importantly, it's an open invitation for all of us to start thinking about it seriously. And that is exactly where this explainer leaves us. The source ends by basically asking people to bring their ideas to the table, to help figure out both the how and the why. So now we turn that exact same question to you. If recreating a mind really isn't impossible, what does that mean for our future? And what's the first step we should take?